Thank you to everyone, obviously, for joining. Thanks for RSVPing. Good to see another good turnout on Mobile London. I hope you're doing well. Enjoyed the bank holiday weekend. Yeah, today we've got a talk from Dragos, Advanced IS Engineer at Tide. Yeah, thanks to him for taking the time out today to do this topic, do the talk, and to speak with you guys. Obviously, as we normally do, guys, questions we'll do at the end, either by chat box or we'll sort of get people to join and talk on the call. But yeah, I guess that's everything my side. Let's get started, and over to you, Dragos.
Hello, everyone. My name is Dragos. I work at Tide, and thanks everyone for organizing this event. So today we're going to talk about some functional programming concepts, and inspired by topics and talks of guys from Point 3, I would like to share with you today some ideas. So let me zip my hoodie and let's start it. So one of the cool and interesting thing that we have in Swift is that we can store information in types and form a computational context. So one of these idea is kind of optional, and with optional, you can have either a value or not. And okay, Xcode, give me some, yeah, cool. Now, they're either value, either not. So this brings us to idea of a functor. So the functor is the idea that we can map on a value. And basically, what does it mean is that we can do a transformation basically on, we can map basically a function into a function that is lifted in the context of optional. And so we can transform it into something new. What does it mean? It means that we have an int here, and we can say that, yeah, add me 1. And yeah, we get kind of a result. Instead of 1, we have 2 now. And yeah, this is pretty much cool. And what else we can do? We can do also a map over none. And obviously, if we increment the value now inside of the none, there's nothing to change because basically there's no value to change. So what can we see now from this is that this kind of computation that happens inside of this map is kind of pure, and there is no way that we can transform a sum into a none. And also another thing that we comes to is that we have a monad, and the monad is also a functor. And what does it mean? It means that we can apply a Flatmap. And what is interesting about Flatmap, we also have this context of an int now, but this time with Flatmap, we can decide over this context. So we can basically fail over or introduce some sort of like conditions on which we can, let's say, something like this. So we introduce, let's say, our condition. And now in case that this will be true, we're gonna say like, nah, nothing. Otherwise, what can we do? We can say, yeah, sum of, we can return sum of our context. And now, what's, okay, we missed this 0, cool. Now we're back to normal. Yeah. And yeah, as you can see, we still have nil, but if we comment our transformation function map, we will have the result that basically we was expecting. So let me just reload it. Yeah, it's playground, you know. And yeah, we've got a value. So this kind of idea brings us to another topic that we have today, which is basically applicative. So applicative, like map and Flatmap, is basically the idea that we want a function and a value that we want pipe through it. So in case of a functor, we was passing a pure function. In case of applicative, we will have something like this. And let's define our applicative as an operator. Basically, we have here two generic types, 1A and 1B. And what can we do here? We basically have a function that will go from an A to an B. And this will be an optional. And now we have an optional A. And all of this will return an optional B. Now, what can we do here? So we need this one. And cool. Now we have an operator without a declaration. Okay, fine, let's fix it. We need the precedence groups. Okay, no problem. Let's say apply with associativity over left. And okay, seems to be happy. And now what can we do here? We have two optionals. So what we do usually when we have optionals? Yeah, we can do a guard. So we can guard over F. And also we have an X. And why is happening in case that we don't have nothing in this context? We can say, yeah, go and return a nil. Otherwise, I would like an F of X. And yeah, it seems to be happy. And now we need another thing to make our applicative work. And this is an idea that we have in functional programming, which is called pure. So let's define a pure function. It's going to be over a generic A. And what we need for a pure function, we need kind of an X, and we need an optional A. So what can we do here? There's not much to do than just saying sum of X. So we've got our pure function. And now what can we do with that? So we can say that we have a pure sum. And let's apply to it a pure of 1 and a 2. So this can be also expressed nicely in Swift in this way. And this is gonna be the same. So yeah, what else can we do here? We can also use our optional type. So we can say an optional over an int, and we can say none. And we go kind of a nil. Okay, So all of this is interesting. Yeah, we kind of like lifting functions into an optional and we fail on the way. So, and somehow apply knows about the context itself. So it knows about the left-hand side, it knows about the right-hand side. So we're starting to notice something in this structure of these functions, and this is basically the structure looks like something like this. So in case of a map, we have an A that goes to a B, and we have an optional A, and as a result, we have an optional B. Now, in case of an apply, we have an A that goes to a B, and we produce an optional. We feed an optional A, and we return an optional B. And in case of Flatmap, we have an A to an optional B that doesn't produce optional. It takes an optional A, and finally, we've got the same optional B. So with this kind of intuition, we can go next with carry functions. Let's say we have an add function that will take an int. Now this int will produce another function that will take an int and will produce an int finally. And this is gonna be looking like that. So we've gone X, we've gone Y, and what can we do with X and Y? Nothing than this in this case. So we've gone up, yeah, nice. And now, like, what can we do with this? We can pure over this add, and now we can feed value like pure 1, let's say, and we can do a pure 2, right? And what we have here, we basically have a function that will go from int to int and will produce finally an int. And yeah, it kind of work. We can simplify this in a more nicer way. It could be something like this. So probably is a bit more readable. And basically, why we're discussing about all of this? Like, what's the point? Like, and the idea is that if we go back to our apply function, we start to see here a sort of intuition. And what does it mean is that we have an F, and we can do a flat map of an F. And what we get here, we have an A that goes into a B, which is exactly an F. And now what can we do with this F? With this F, we can basically take our X and we can map over X, and we've got a function that will take an A. So what can be this function that we can basically do it here is nothing else than just getting again the X and feeding it into the F of X. And it seems to be happy. So now in your code base, whenever you see this kind of like God of flat, and after that you have like an E flat of other optionals, and you go an else that returns nil, and other and next you can do like again a return of another function. You can see basically this kind of intuition of flat map and map. It could help you to reduce this sort of like godlet and E flat and make code a little bit more nice and a little bit more readable. And of course, we are still able to fail of our apply. So we can say like, we go a new and it's going to fail. So yeah, nice. Let's go next. So let's discuss about maybe a more real example. So let's say we go a song, and let's try to represent a song. So let's say it's going to be a structure, which will be a song, and what can we have in this song? So we can have an ID, which will be an int. So ID will be the like unique, let's say song name, and we can have a kind. So what I mean by kind is that you can have like MPEG, MP3 formats, you can have like a LAC, AC, FLAC, whatever formats. Let's consider for now like AAC, which is basically an M4A format for this exercise. So let's say we can play only songs of this format. And now let's create a carried version of this song structure. And yeah, as we did before, basically we know that we can have create like a song. And what we can do in order to satisfy our carried function is, again, we have an ID inside of song. We also have kind, and all of this is part of a song which can take ID and obviously kind. So Sweet seems to be happy. Now what can we do with this? So we can pure create song. Now we can feed values. So we can say the ID is going to be 1, and the format, as we agree, will be M4A. Nice. So what else is interesting here is that we can basically use new, and when we use new, we get a failable initializer for our structure for free. Basically, we didn't add any code here or something. So it's just something that we get for free. Now, okay, but the problem is that in this sort of example, in case that we fail, we get a nil, and not all the time a fail over a nil is what we want. Because maybe we want to show a message to our user or something else. And here comes another idea that we have in functional programming and at all in programming, which is called validation. And let's suppose we have a validate function that will validate our IDs. So what we have in case of ID, we've gone int and we return an optional int. Now, what can we do here? So suppose our app cannot take IDs for a song, that will be a negative value. So we can take values that are greater, basically, than 0. Okay, so let's say it's bigger than 0, and what can we do? In case that, yeah, it's bigger than 0, like let's do a pure ID. And otherwise, let's say none. Okay, seems to be happy. Now let's do the same validation, but for kind. In case of kind, we have a string and we want to return an optional string. Now, what can we do here? So we go our kind, and we can say that if our kind contains our format, then we have pure kind. Otherwise, nothing. So cool. Let's now give it a try with our pure things. Let's use here, instead of pure, our validation function. So we've got validate for ID and validate for our kind, which is M for A. Okay. So what's going on? We probably missed something.
Should you just create song?
Yes, thank you very much. Yeah, because basically we in context of the song now. Yeah, thanks. You can help. It's like a group exercise, let's say. So yeah, we take our song, we lift it into the pure, we applied it to a validation one, and we apply it to a validated already and for A, and seems to be happy. All is good. And oh, by the way, we can fail. So yeah, in case that we fail, we go a new, and in case that we give a wrong format, also. But now the problem is that we don't store kind of this information. So again, we came to the same new. Basically, there's nothing that will tell us what's wrong. But in the same time, we have some small components. We have like some interesting sweep behavior, and we have optionals. And basically, we have some interesting behavior here. But let's not stop here, and let me go to the result type. So basically, in functional programming, we have a result type or a ether type, which is usually a num that is a result with an error and a success. So we have two cases, a case where we have a success and a case where we have a failure. Now, now result is a functor, and because result is a functor, we can do a map. And let's define a map function over a generic B that will take an F that will go from an A to a B. So what we need here, we want finally a result. We want a result that will have an error and the B. So what can we do here? We now inside of an enum. There's nothing else that you can do than switch. So yeah, let's switch. What can we switch? We can switch over self, of course, and we don't need this default thingy. What we have here when we switch over, so we can bring in front our LED, and we go a success over next. Now, what can we do with this value? So we can say that return me, please. So what I need a B, but in order to produce a B, I can't just send here an X. I need somehow to produce an B, and in order to produce an B, I need to feed something into F, and I can feed into F an A, and an A in our case is the X, and we can do a success of them F of X. And now let's see what's going on with our failure. So what can we do here? There's nothing else to do than just return a failure. And everything seems to be happy. Now, of course, result is a monad, and because result is a monad, we can define a flat map. And yeah, let's do it. So we've got a flat map in this case, again, with a generic B and what we have here. So we've got an F that will go from an A, but this time we want to produce a result of an E and a B, okay? And all of this is gonna produce again a result from E and the B. So again, we now inside of the enum. What can we do here? Switch. Self. Okay, we don't need all of these things. Okay, cool. Now, yeah, what's next? So we have a success again and a failure. So let's see what can we do in case of a success. Again, we have an X. What can we do? So this time we will return an f of x. And in case of the failure, we will return failure. So good. We have result, we have success, we have failure, we have like map, we have flat map, like nice. So we have the ability now to change the context from success to failure. And what we miss is the pure function. So let's define our pure function. Now here we have an ENA, and again the same intuition that we had before. We've got an A, and now we need to return a result of E and A. Cool. So how can we make it pure? Yeah, let's do a success of X. Cool. So seems to be happy. Now let's define our operator. Yeah. Okay. We don't need this for now. So what we have now, we're going to pass an A and a B. Now we introduce E. Okay, we've got E. Now let's see what can we do with our F, X, and what we want to return. So in case of the F, what can we do? So let's say we need the result of, and we have error, and we go from A to a B. Okay. Now we need to feed something into this F, and what can we do here is to use the result of an E and A, and now we want to produce finally a result that will have an E and B. Okay. So we have A, B, E. We have an F that take an E, an A and a B, and we have a result of E, A, and we finally return an E to B. Now, how can we fix it? And you may start notice something. So if we copy paste this and we put it here, it works. So basically, we have some universal intuition here that we kind of applied now in different places, and it's still valid, and it still brings sense, and it still brings results. So, and always is something that we expect. So this is very cool. And what we can do now, let's let's change a bit our validation functions. So now instead of returning an optional int, let's say that we would like a result. So what we want with this result, we need a string where we're going to store our issues like errors. And also we need the value itself, which is basically our int. So now what can we do here is that we can say, look, fail me with an invalid ID. Okay, now let's bring the same idea to our kind. So we go a result. We're interested again in the string, which will be our error, and the second one is the kind itself, which is a string. And we can say, yeah, fail please with the invalid kind. And yeah, now let's play a bit with this. So cool, we go a song which with an ID and with a kind, which is basically validated. Now let's do something bad. And we go an invalid ID. Great. Now what we can do, we can change this into this format. And we also get an invalid kind. Nice. Now, what happens if we have an invalid ID and an invalid kind? As you may notice, we basically fail over the first validation. And doesn't matter what's going to happen next, we kind of don't care for now. And maybe this is okay for some sort of like for some ideas, maybe for some application, but this is not always the case. And basically, it's not always what we need. And in order to fix this, we can adjust a bit our apply operator. So at the moment we're using a Flatmap. So yeah, let's not use Flatmap for now. Let's think about something else. And what I mean by something else is that let's come back again to our switch. And we have here an F and we have an X. And basically they both kind of have this behind the scenes and enum. And when we discuss about enums is again a switch. So what can we do is we can switch over F and X. So let's do it. Now we switch over F and X. Now let's go again let me remove these things. So let's do a case analysis over F and X. So what can we have? We can have a success and we can have something that we don't care for now, like a failure. But if it's success, it's success. So let's say we want to return a map with an F. And okay, we have something, but seems that is not all what we need. So let's continue. We have a failure. Also, we can have a failure, which is an E, and we can have a success. Okay, and so what happens? We have a failure and we have a success. Yeah, we're gonna return a failure. Failure. Okay, great. Now, but yeah, it's not in the dot. It's not everything yet because we left another case of a failure which have an error and a second failure. And oops. And now what we can return here is that failure that we have. Okay, we have the switch and everything seems to be happy. And yeah, let it reload for a sec. Okay, but again, it's basically showing us an invalid ID. And what can we do here is basically we can move our E to a second failure. And in this case, we will have an invalid kind. So we can have first fail and let's say a last fail. So we kind of have a little bit of control here, but is it what we want? Maybe yes, maybe not. Maybe we want to collect all of these things. Maybe we want all of these things to be together. And there is an interesting thing in Swift. So we can limit our E to a range replaceable collection. And with this, we can bring back our E. And let's say we have error 1 and error 2. And now we can do error 1 and error 2 together. And the result is, yeah, almost what we want, but still it looks very weird and it's not very readable. Why? Because it's a concatenation, and yeah, this is what we get. But we can fix it. We can do we can transform our error to an array like this. And this. And now it should have both in an array. Cool. So we've got a kind of like accumulation. We have an array of errors, and yeah, basically we didn't use the Flatmap, and in favor of Flatmap, we can use apply to have this little control of the errors and accumulation, because Flatmap is how it works. It's basically you get a failure and stop, and it doesn't care about if you're gonna fail again. But all of this, okay, is interesting and good to know, and all of this can bring us to another idea, which is future. So recently it was introduced also in the suite. We have it in the library. But like, what's the idea? Maybe you heard about like future, probably like there's lots of talks around of this thing, but how it's actually work. So it's a class, let's make it final, which we will say future over a generic A. Now, what can we have inside of this future? We can have an F, which will take an A, that will produce a void. And now all of this will produce another void. Okay. What's next? No initializer, right? Class future has no initializer. Okay, let's do it. We've got an F. And what's the type of F? Is okay, let's give it the type. Now, what can we do? F is F. So yeah, what else? Cool, let's fix this issue. We have escaping, yeah, nice. And it seems to be happy. So what can we do with this? We can say we have a future, we can in, and we have that in F, so we can feed it a value. Now, okay, we have this. We can express this in this way. Also, Swift allows us to do things like that. And as you can see, basically, we have already here this context that we was talking about previously. And what if we can somehow read this context? And in order to read this context, we can use, usually it's called something like onResult. And what is this onResult? It's nothing else than a callback that is an A that goes to a void. And what can we do here? We can basically call an F with a callback. And what's happening here is that now we can say onResult to go on int, and we can print this int. And let it load, and it's 1. Okay, nice. This is of course very interesting, but like, what's the point? And just to continue this, let's add a map and map. Because as we know, with the map, we can transform things. So let's add a map. What's with this map? Again, it's basically over n generic p, where we again have a function that will go from an A to a B. And all of this will produce a future B. So what can we do here? We want to return a future of B. And of course, we have an F. Now, what can we do? So we introduced these kind of things that was onResult. And what is doing this onResult? Again, is giving us access to an A, which we can consider now an X. And we have an F, we have an X, and we have a function G that goes from an A to a B. So what can we do here? We can say that if we feed, where can we feed our X? In a G, right? So we can say G of X. And what can we do with the result of G of X? We can apply this to an F. And now is escaping thingy. Okay. Okay, so let's make it nice. Okay, now let's discuss about Flatmap. So what about Flatmap? So Flatmap is, again, we have a B. Now we go to a function that goes from an A to a future of a B, and all of this will return a future of a B. So we go from an A to a future of B, right? Now, in order to produce a future of B. And now what can we do? Again, we have the future of a B. Now we have again our F. Now, well, we have our own result where we can get our A. And what can we do with this is basically we can take the X, but where can we take the X? We can take it only from the own result, right? And there's no other way. So we have an X, and what can we do with this X? We can feed it into G, and once we feed it into G, we have a future of B. And how can we kind of return this and apply? We can do an on result on an F. And everything seems to be a little bit happy. Yeah, we need escaping. Okay. Yeah, okay, so now we define a map and flat map. Now, what can we do with this map? We can say, yeah, let's change some values. And, oops, let's say this. Yeah, we've got a value. And we've got 2. And yeah, cool. So we've got a map, we can change values, we can read the result, but we didn't use our flat map. And why we didn't use the flat map? Because we have our apply function. And let's get it back from where we left it. How can we make this work? Again, we have an A and a B, but now instead of an F, we will have a future that will take basically an A that will go to a B. What about X? It's a future of an A. And what about B? It's a future of a B. Yeah, it's still okay. So what we're missing here, as you may notice, basically is the pure function. So let's go to our pure. Again, we have an X that will take an A. What can we produce? Yes, the future of A. So now how can we do this? We have a future of an A, right? Now we have an F, and we have an F, which can take an X. So this will be, okay, now we have a conflict from our previous apply. Let's just quickly comment all these things that are failing. Okay. Hopefully there's not much left. This one's, yeah, it should be fine. Okay, so we're back. Now let's say that we have a pure, so we have a pure add again. And now what can we do with this pure add? Let's say we can add 4, pure 4, let's say, and let's do a pure whatever, 2. And now what can we do with that? We can apply on this thing our on result and get the int from this. Okay, so what can we do? Just printing, and yeah, it should be still happy. Yeah, nice. Now, okay, these things happens that sometimes we want a delay version of this kind of feature. Sometimes there are operations that will run for a while, and they could be like seconds before something is happening. So let's discuss a little bit about this sort of situation. And for this, we will import the dispatch. So let's create a delayed function that will take again. This delayed function will look kind of the same as pure function with a little bit of addition. Now, go again, it's the same as our pure function. Nothing else. To come back to our future, we've gone F. Okay, so what can we do here? Let's say that we want to just to make things a little bit more visible. We can say, okay, we can say, look, let's do a bit of delay. And how can we do this delay? We can use dispatch and there is a function that takes time and a callback. So let me find it. I think is this one. Async after, yeah, this is the callback, and I need the time that will be, let's say now, and 2 seconds. And what we want here is, let's say we want to print this little thing when we're done. And when we're done, it means that we apply f of x. Okay, no problem. We basically need an escaping move. So let's see where we miss some escaping. It could be this one, maybe. Escaping. And okay, yeah, wrong position. No problem. Let's do it here. And again, we need an escaping. And again, and escaping. And seems to be happy. Okay, we're back to normal life. Now, basically what I want to do is let's come back to our pure little thingy. So we've got the pure. Now instead of pure, we can use delayed. And it's going to do, as you can see, it's doing a delay, a done, a delay, and a done. Let me comment this now. And we have something else somewhere. Yeah, okay, nice. Now it's a bit more readable. So we've got a delay, a done, a delay, done, and 6, right? 4 and 2 is 6. So all of this is okay, how it works, but still we can do 2 requests in parallel. If you remember in the beginning, I was kind of zipping my hoodie. So it was basically intentionally, because basically zip was something that kind of work like this. So you have this little 2 thingy that are prepared, and once they prepared, you are happy to zip up kind of. So let's see how it works. So let's define a zip function that will have an A and a B. Now this function will take an X, which will be a future of an A, and we can have a Y that will be a future of a B, and all of this goes into a future of an A and a B. Okay, so what can we do now? We have a future of an A and a B. And what we have? We have an F. And basically what for now is what we have with our future is that we have a map and a flat map, right? So what can we do here? We need something more to make zip work, and this is the result. And we need a result thing that will cache kind of. So let's introduce the result property to future. That will be an optional A. What can we do with this result? So when we inside of on result function, what we have an F and we have an X, and we can say, okay, result cache. Now callback as we had before over next. And we don't need this anymore. Okay, so we cache it. So now that we cache, we kind of have a property result, right? Which is an optional. So we can ask values now. Let's go back to zip. So we have an F, right? And also we have an X and a Y. So let's say X on result. So what do we have on the result? We have again our X that goes into something that we introduced was result. So we can access now result, but the problem of result is that is an optional B. And we know what we do with optionals. We flat. Now we have an honest Y. What can we do with this honest Y? We can feed it into our F. So cool. Now let's do the same thing for Y. Okay, we have a Y here. Let's subtract from x the result, which is an optional. Again, we need an if let. We have now an honest x. So what can we do with this honest x? Is this. Okay. And Swift seems to be happy. Cool. Now, what can we do with this zip? Let's go back to our lovely apply. Cool. So we have an A. We have an A. I actually can do it straight here. So what we have here, we have an A and a B, a future that goes from A to B, and an X that take a future A, and we produce a future B. So let's use our zip here. So let's try to do this. So we have a zip. What can we feed? So we have F and X. Now, what can we do with this? We know that we can map. And once we map, we get a context of an A that goes to a B and an A. It's nothing else than F and X. So what can we do with F and X? We can do F of X. So now we get concurrency for free. So obviously you will need to spend some time to kind of make it work and like check and all the stuff, because there's lots of like things, but it kind of worked, and it let us discover some interesting things. And if you know, in the past, when Apple was kind of doing presentations and different events, they always end up with some sort of songs. And of course, we mentioned today about songs and so on, and hoodie and other things. It wasn't like, it has a reason. And the reason is this. and yeah, let's let it go a while. Evening, functional programming. Again, morning, the foxes are yawning. Lockdown stage 99, I know it's boring. Hey, what's up? Reciprocal from Tommy. Hey, how are you? Same cool things going? What about meetup? Yeah, let's do it. What about subject? Maybe functional programming. Okay, cool, sounds good. See you later. See you later. So yeah, let's go back to our world, and thanks everyone for joining this, and I hope you enjoyed. And now it's time for questions.
Perfect. No, thank you, Dragos. Yeah, like you mentioned there, does anyone have any questions at all? If you want to put that in the chat box or turn your mic on, anything that you're keen to obviously ask Dragos about what he's done tonight. We'll wait a moment. Yeah, feel free to put it in the chat box, or sometimes if it's easier, just turn your mic on. They should all be muted, so if you want to ask anything, feel free to ask now.
Yeah, if you have any question also, you can find me over LinkedIn or any other social things. Happy to discuss.
Yeah, what we'll do is obviously this call is recorded, so if anyone obviously wants to share this or has any questions, like I say, I'll tag Dragos on sort of the call on LinkedIn or put his profile on there. So if anyone has any questions at all to get that across, if they ever think about it, yes, thinking sure that more than happy to answer that. But no, I think that looks like it's it. I can't see any messages coming through, Dragos. But no, thank you very much for obviously taking your time out tonight to obviously speak with us. Thanks for doing it all. Yeah, I've just seen in there, Dave, but thanks for the great presentation and obviously the song as well. But yeah, no, thanks for taking your time out, mate, and really appreciate you doing this.
Thanks, Tommy, for hosting. And yeah.
No worries. No worries. Well, look, thank you, everyone. Like I said, any questions, feel free to ask him. Obviously, have a LinkedIn.